Hello folks, we are coming to the part 4 video. We were doing the miscellaneous exercise of chapter 1. We finished in the 5th question. Now it is the 6th question. Probably we'll also take the 7th in this video. Right. Now the question that is given over here is that they give us power set of A equal to power set of B. They are equal. And they ask us to show that A equal to B. When the power set of two sets are equal, you are supposed to show that the set is equal. That means P of A equal to P of B is given. Show that A equal to B. Long ago we have learned that if A has to be equal to B, we do it in two parts. We have learned one of the ideas of showing the set theory is that we will show it in two parts. One is that A is a subset of B, and we will take maybe B is a subset of A. And when we have both this together, that's how you will have A equal to B. This is the idea that we are going to use in the problem over here. Now, because the steps are exactly identical, we will just do one part and the other part will follow on the same line. So that's how we are going to go about doing it. So what we will do is, in order to start the proof, as we know that when we have to show the subset, we will take an X belonging to A and then somehow with whatever working we have, show that X belongs to B. Then in that case, you get A as a subset of B. So that is going to be our working. So let's start right away with X belonging to A. So for the first part, let X belong to A. Now if X is belonging to A, what does it mean? That if you take a set of this element X, then it will be there in the power set. Power set of A means what? You collect all the subsets of A. That will be called as a power set. So if I happen to make a set X like that, then it becomes a subset of A, and if it is a subset of A, automatically it will belong to the power set. So this means that, therefore this means that this belongs to the power set of A. Now, if the singleton X is going to belong to power set of A, it will belong to power set of B. Why? Because power set of A is equal to power set of B. So as a result, we will also have, this also implies that X belongs to power set of B. But we can apply the reverse definition as we applied over here. When we had X belonging to A, the singleton X was belonging to power set of A. Singleton X, because it is belonging to power set of B, X will belong to B. The same idea. So therefore you have X belonging to B. That's it that we wanted. We started with X belonging to A. We have reached X belonging to B. It is going to be a subset. So we can say thus, starting with X belonging to A, we have reached X belonging to B. That's how A becomes the subset of B. We can call this as 1 and we can say similarly. Because the steps are exactly identical, similarly B is a subset of A, or it can be proved. B subset of A can be proved. Same way, on the same lines. And that we could call it as 2. So, we could get, therefore, from 1 and 2 together, we are able to get A to be equal to B. That's how we get A to be equal to B. This is one way of showing two set, whatever collection is given to us are equal. One of the ways. There are different ways of showing collections equal. This is one of the ways. Now we take the question number 7 and let's check what is given in the question number 7. Question number 7 says that, is it true that for any set A and B, power set of A union power set of B is equal to power set of A union B? Justify your answer. Is it true that? That means whether it is true or false. So logically it's a false statement, doesn't happen like that. Now we have learned in the exercise 2 itself, they have told you, and I have told you that we have to keep in mind that whenever a statement is true, we have to give the proof for giving the reason, and whenever a statement is false, we just have to give a counter example. So we are judging that the statement is false. So if the statement is false, we should be able to give a counter example. So we devise an example and see how this happens. So let's see. So maybe you can call a solution to this. What we are going to do is, this is a false statement and we are going to give a counter example. This is a false statement. And what we are going to write is a counter example. The counter example is what we are going to write. We can choose any set as a set at random, but then always when we make examples, it's always better you choose a set as small as possible so that your working is also reduced, right? So here, let's take an A, maybe it's a singleton set. You can take B also as a singleton, or you can take it as a doubleton, that's your wish. Or you can take with alphabet A, B, C, that way, that's all your wish. Or if you are very interested in Greek alphabets, you can take alpha, beta, gamma, that way also you can take. Or you can take Roman numerals and you can take, or you can take normal numerals and take, that's all your wish. Right, so this is how you have your set. Now, we will look at, see, all these things we'll keep ready so that we can get to know what the thing is all about. See, somewhere we can see unions happening. So let's see what is A union B now. If A is this and B is this, then A union B logically is 1, 2, 3. It's very clear to us that A union B is 1, 2, 3. That is done. Then they are talking all about power sets. So let's find out the power set. Let's first find out the power set of A. Power set of A are all subsets of A. Singleton sets, they will have empty set and itself as a subset. That is all that is there. So you have Phi and A as a subset. Then power set of B, it's a doubleton. So we'll have to take all the possible combination. We'll have empty set. We'll have singleton 2. We'll have singleton 3. We'll have 2, 3 or B, whatever way you want to write it. These are all the subsets of B, and that is why it is coming in the power set of B. Then we will have to also find out the power set of A union B. Power set of A union B, it's a triple, the set has got 3 elements. So what we will do is we'll gradually take all the subsets. First it is the empty set. Then we have all singletons. Yeah, we have all singletons. Then we will take up all doubletons. So 1, 2, 2, 3 and 3, 1 or 1, 3, whatever way. Then we will take, these are doubletons are over, then the set itself. So like that, we have got, this is the power set of A union B. Now, let us see how the statement works up. This is ready with us. Let's find out what is power set of A union B. So, a power set of A union power set of B. Therefore, power set of A union power set of B. What does it come to? Power set of A is empty and A. Here also empty is there, so we don't write it. Here we have singleton 2, singleton 3, singleton 2, 3. Okay. So, when we compare power set of A union B and power set of A union power set of B, let's compare these two. Are the elements exactly same? No. This set has got some extra elements which are not there in this set. So, because both these sets don't have the same elements, the set is not equal. And that is how we justify that our statement is false. So, we can write, we observe that power set of A union B is not equal to power set of A union power set of B. That's how we get across this example, and that's how we prove the statement false by giving this counter example. That's all in this video. We come to the with the later questions in the next part of the next video. Thank you.